Okay, the experimental part of the fifth lab is pretty straightforward. Uh, all we need to do is construct this circuit, this RC circuit, and find the frequency response of the resistor voltage and the capacitor voltage. So we need a 10 kilo ohm resistor and a 10 nanofarad capacitor, which we have. As usual, we have our analog discovery device, our breadboard. Let's construct the circuit. Here's our resistor. And the capacitor. Okay, we have the RC part. Let's connect the waveform W1 from the analog discovery device. We're gonna ground it, ground the circuit as usual. I'm gonna ground it here. All right, so we need to measure the voltage across the resistor and across the capacitor, right? So this time, we're actually gonna use two channels, not one. So let's go back to our analog discovery. As you can see, we have two channels, 1 and 2. So we will take the first channel and plug it in across the resistor. Right. It measures the voltage across the resistor. And then we have our second channel, right? That we've never used before. We're gonna take that and plug it in across the capacitor. Here. All right. The first channel is across the resistor, the second channel is across the capacitor. Now let's go back to our waveforms. Right, let's go back to the PDF first. So we will apply a sinusoidal with the amplitude 5 and 0 phase, and we will change the frequency. Let's do that. We go to wavegun, sinusoidal with amplitude 5 and 0 phase. Okay. Now, using the frequencies provided, let's go to the word. So we're going to start with 400 hertz. Let's do that. Okay. Now let's go to scope. And there we have it. That's fine. Okay, nice. So one thing to note here is, so the input waveform starts at 0, right? One thing you should immediately observe is the resistor voltage, which is on channel 1, the yellow channel, the channel 1, is in phase with the input voltage. The capacitor voltage is out of phase. As expected, it's the second channel, the blue channel. Now, what we should do is we should find the amplitude of VR, VC, and their phases in degrees. Alright, so for this, we will use measurements. And here we have the maximum of channel 1, which is around 115 volts. Let's put that in. Let's find VC, add define measurement, I believe, yeah, channel 2, maximum. You can find the RMS voltages here as well. It's around 4.74, let's say. I'm sorry, not here. Okay, now the phases. So first of all, let's find the phase of the resistor voltage. Now, it looks perfectly in phase, but let's actually check it out by going to data. Stop this. So what we're going to do is we're going to actually find the zero crossing of the resistor voltage. There we go. Like it changes the sign, the negative to positive sign, somewhere very close to zero, which is practically zero. So it is actually perfectly in phase with the input voltage. So its phase is zero. Now we said the capacitor voltage is out of phase, and the phase measurement actually shows that. Like it literally finds the phase difference between channel 1 and channel 2, and it's around 85.2. Let's write it that way. Right, so all we have to do now is just to change the input frequency. Let's write it this way and record these maximum voltages and the phase difference. So I will do that, put all the values here, and then you are supposed to use these values for further, plots, comparisons, calculations, etc.